Alright, so in this short video we're just going to go through some linear modelling questions which could be on your exam, and you've also been assessed on this, but we just want to spend some extra time on it because one of your units, one of your modules for next year is graphs and relations, in which linear relations is a big component, and also linear programming. So let's just get started and just get started on this example here. So for this example, water is pumped into a tank, and the volume in litres after t minutes is given by this equation. Now, I'm not sure why this won't. Okay, finally we get there. All right, so we're looking at this graph. How much water is in the tank at t equals 0? Well, a lot of you must realise that at t equals 0, we want what we know as the y-intercept, but it's not the y-intercept, is it? It's the volume in litres. If we've got volume as a function of time, yes, some function of time with a gradient plus the y-intercept, or the v-intercept in this case. So be careful. What is that v-intercept? It's at 200. This value here is at 200. So at t equals 0, the volume in the tank is equal to 200. How much water is in the tank after 10 minutes? Well, that's just really getting that point here. So at t equals 10, the volume is equal to 1200. Pretty straightforward. And the tank holds 2,000 litres. How long does it take to fill? Well, it initially has 200 litres in it, but when we get to 2,000, so what we want to know is when V is equal to 2,000, T is equal to 18. Now, be careful, don't say 18. This is litres, How long does it take to fill? It takes 18 minutes. They could ask you in seconds and such. So find the equation of the line. Well, first of all, we know that we've got V is equal to the gradient, we'll call M times T plus C. Now we know that C is equal to 200 from over here. So we've got our equation is V is equal to MT plus 200. Now what we know is from the previous question over here, we just know a point, and we can substitute that point into the equation. What we can say is that when t is equal to 10 minutes, V is equal to 1200. We've just extrapolated that straight from the graph. So what we're going to do is we're going to sub in this 10 to 1200. So we've got to have 1200 is equal to M, which is the gradient, times T, which is 10, plus C, which is 200. So therefore we've got 1200 is equal to 10M plus 200. And then I'm going to subtract, we could do it in our calculator if you wanted to, but I'm going to subtract 200 from both sides. I've got 1000 is equal to 10M. And dividing both sides through by 10, we're going to get that to be 100. So therefore, we now know that our equation is equal to 100, the gradient, T, plus 200. How many of you got that one right? Did you get that one right easier? Yeah. Okay, good. Use the equation to calculate the volume of the water in the tank after 15 minutes. So what we want V when T is equal to 15, which 15 times 100 is 1500 plus 200 is 1700. So therefore, V is equal to 1700 litres. All right, and at what rate is the water pumped into the tank? That is, how many litres are pumped into the tank each minute? Well, if you think about it, if we've got V equals 100, was it 100T? 100T plus 20, For each minute that is increasing, how much is the volume increasing? 100 litres, isn't it? So therefore, at what rate? We can say 100 litres per minute. And that is actually the gradient, rise over run if you like. We can look at that and we can look at a point on this graph. Let's just say from 4 to 8. From 4 to 8, what's the rise? What's the rise? It rises from 500 to 900. Okay, so we can say 900 minus 500. And the run is from 8 to 4, so 8 minus 4, which is equal to 400 over 100, which is, of course, 400 over 4, which is equal to 100, and that's in litres per minute. All right, so hopefully so far so good. These are... What's that? What do you mean? 1,000 what?
When T was 8, volume was 1,000 litres.
Yes, that's 1,000. Yep. 1,000. Yeah, but this is also 600. So yeah, it's still the same result, isn't it? Yes, you're right. That's still 400 over 4. Yeah. So thank you, Luke. I just was rushing a bit there. Now let's have a look at segmented line graphs. Now what we do is a segmented line graph is essentially two lines. But you can see here that when x is equal to 3, we actually use this graph, the second one. So what we've got to do is we've got two graphs. We've got two lines. We might have one which has a higher gradient, so one line which has this gradient, and one line which has a gradient such like this. Okay, but the thing is they're segmented, so we're only concerned with the values of x between 3 and 8. We're drawing that line there, and between 0 and 3, non-inclusive though, we're using the first line. Now, it says use an appropriate equation to determine the cost. Now you can see here that the cost in terms of x is 2.5. Which equation does it go into? Does it go into this one or does it go into this one? Well, we're looking at values of x which are less than 3 in this case. So therefore, we've got to use equation 1. So what we've got to say is we want c of 2.5. Oh, I'm getting this whole bizzo here. Let me just, we're just going to resume. So c of 2.5 is equal to, so we're plugging into equation 1, and that is when x is equal to 2.5. We're using this one here because it fits within this domain. So the cost is equal to 50 plus 40 times 2.5. That's going to be $150. What about over here though, 3? This is non-inclusive of 3. You can see there that it's at that less than sign. So I'm going to just show you there again. You can see there that it's non-inclusive of 3. So rather than going into equation 1, we've got to go into equation 2. So what we've got to do is the cost at 3 is equal to 80 plus 30 times 3. 30 times 3 is 90, so that's $170. And the cost of 6 metres of rock is equal to, we're using this equation again, so we're looking at 80 plus 30 times 6, which is $260. I hope most of you got that one right as well. Now use the equations to construct a segmented graph from 0 to 8. Well, what that means is that we've got a graph. So if I draw my axes, first of all, can you get negative rock? I'm only looking at positive values. So we're going to say that this is our x-axis and this is our c-axis. And we're looking only at values between 0 and 3, but non-inclusive. So what's the y-intercept or the c-intercept? The c-intercept is 50 for this first one. So I'm going to put a 50 up here. Try to keep it nice. And then I'm going to put 80 up about here. So equation 1 is what we're drawing first, and we're drawing it between x equals 1 and x equals 3. So x equals 1, 2, 3, 4, 5, 6, 7, and 8. Now you could draw these in your CAS calculator, or we could know that we can do it by hand. But the thing is, what is the c-intercept? The c-intercept is 50. And it's a positive graph. But the thing is, what we need to do is find where that endpoint is. Now, let's have a look. When x equals 3, then the cost for this first graph is equal to 50 plus 40 times 3, which is 170. Now, we go up to... So let's just say this is 170 up here. Our line starts here at c equals 0, and at c equals 3, it goes to 170. But the question is this a closed circle? Is this a closed circle over here, Amanda? Is it a closed circle over here? Is this a closed circle or an open circle that goes here? Is it inclusive of the point 3? Is the first equation here inclusive of the point 3?
Yes. No.
Think about it.
No.
No, it's not. So, oops. So this point here is where you've got to be careful. This is an open circle, because equation 1 includes the point. If we draw it on a number line, includes the points from 0 to 3, but it's non-inclusive of 3. And the second thing is we've now got from points 3 to 8. Let's sub in when x equals 3 into that equation. Well, we have done that, and that's 170. So what we've got is we've got 170, and it's inclusive of that point, but this time it's got a smaller gradient. It's got a gradient of 30. So we actually do include that point because it's inclusive. It does include the point 3, 170. And what is the end point when x is equal to 8? So what we've got to do is we've got to sub in. We've got to sub in and find the end point, and we've now done a segmented graph. So when x is equal to 8 into this, x is equal to 8, our cost is equal to 80 plus 30x, 30 times 8, 240 plus 80 is $320. So what we've got is, and of course you would have more room, but this line goes from here up to here. It's inclusive of that point, and then that point there has the coordinates of what? Has the coordinates of 8 and 320. And that's a segmented line graph. Okay, so what I'd like you guys to do is now have a go at the questions from 3G, linear modelling questions, because I know that you didn't do so well on some of those questions in your CAT. All right, I'm going to stop the video now.